Hey everyone, thanks for joining us today. Today's Proof of DeSci episode is all about Cocoa Zero, a research project that's pushing the boundaries of sustainable biotech. We're joined by Dr. Rodrigo Ledesma-Amaro and Dr. Oliver Konzock from Imperial College London, the brilliant minds behind the Cocoa Zero research project, who will be sharing their insights into how they're using synthetic biology to create a sustainable, scalable alternative to traditional cocoa production. And we're also obviously joined by Albert Annis and Morgan Richards from ValleyDAO. And ValleyDAO, FYI, funded and powered Cocoa Zero research project. We're also going to dive into the future of DeSci and how projects like Cocoa Zero show that decentralized science is real and can drive impactful, world-changing innovations. And I'm Tom, your host today and head of marketing at ValleyDAO. I'm super excited to kick off today's episode of Proof of DeSci. So sit tight. Get ready for a fascinating conversation, and feel free to drop your questions in the chat as we go, or at the end, towards the end, there's going to be a little Q&A session as well. And let's make this an engaging, insightful discussion. Let's get started, guys. Rodrigo, Oliver, super pleased to have you here. Maybe before we actually start, you could introduce yourself to our community and give us a little insight, a little overview to your background.
Should I start? Great. So, hi everyone. I'm Rodrigo Ledesma-Amaro. I'm an academic at Imperial College London. I'm also the director of the Bezos Center for Sustainable Protein and the director of the Microbial Food Hub, which are two institutes working on the future foods. My background is in precision fermentation and synthetic biology. So I've been working for the past 15 years, engineering different microorganisms to produce different products, always having sustainability in mind and how can we can move away from petroleum and other unsustainable ways of producing chemicals, fuels, pharmaceuticals, materials, etc. Lately, we've been focusing quite a lot on food and food ingredients, and I think that's what we're going to be talking about today.
Amazing. Thank you. And Oliver, would you like to give a little introduction to yourself as well?
Yes, thank you for having us today. My name is Oliver. I am a postdoc in Rodrigo's group. I did my PhD in Chalmers University in Gothenburg, Sweden, where I was working already on genetic engineering of yeasts and food applications. And for the last year, I have been a postdoc in Rodrigo's lab here in Imperial College, working on Cocoa Zero, on the project we talked about today.
Awesome. Thank you so much, Rodrigo, Oliver. Albert, Morgan, you can also introduce yourself. However, I know for a fact that our community knows you very, very well. So, if you want to, you can introduce yourself. But I also want to start with a question to Albert and Morgan. Can you actually tell us a little bit about the Cocoa Zero research project and what inspired ValleyDAO to get involved with that?
Yes, absolutely. So Albert speaking here. I think what wasn't specifically what inspired this project. It's more like back in the days when we were starting out ValleyDAO, the concept of DeSci and like traditional funding models was very esoteric for a lot of academics. And Rodrigo actually was one of the few academics who was like very open to it and decided to basically give us a chance to work together with him, which ultimately resulted in the funding of this project. And I think like it was also, honestly, we were like one of the first researchers at the beginning. I can speak more on this, but Rodrigo is known for being one of the primary, the key researchers, particularly with Yeroia lipolytica, which is the strain of yeast that is really efficient at producing high amounts of lipids. And so we explored different target end products that we could, because you can make everything from fuels to food ingredients. Cocoa Zero is a food ingredient type of product. So yeah, that was like really the genesis story for how we started working with Rodrigo. Rodrigo was just very open-minded, which was really, really beneficial to us and helped us bring this project over the finish line at Imperial.
He was also on one of our first ever videos that we shot, which was it's nostalgic to think about that shoot and where we were at then and where we're at now. And it's great to be able to still sit at the same table and hear about even the progress of the research, because back then it was all just speculation and seemed very far into the distant future. But now stuff is happening and results are coming out, and it's yeah, it's awesome to be able to revisit these conversations.
Absolutely. And guys, so we've recently actually been releasing short videos that actually feature Oliver talking about Cocoa Zero. But that's actually a super question to start off with Rodrigo and Oliver, actually, because before you didn't actually even know that it's going to be called Cocoa Zero. And I know Albert really wanted to ask you what do you think of this name for this research project?
I think it's quite cool. I would say we didn't even know that we were going to be working in cocoa at all when we started, the project. We knew we wanted to work on lipid-derived molecules that can have an impact in sustainability in the world, but also in people's health. That can also be commercialized, and that's an important angle as well. And for that, we need to bring cost down and all other kind of consideration taken into this project. So I think the Cocoa Zero name has this sustainability aspect in the name itself. I think with the zero indicating this kind of way to make circular economy, zero waste product, and zero pollution as well in the process, ideally.
And just a comment on the name itself. We Rodrigo, sorry for not advising with you on the name itself, but I'm glad that you like it. I was in a position where we really need a name for this project internally, but also externally, because we kept calling it the Imperial Project and nobody knew what it was. It wasn't something that became rememberable. And me and Tom were essentially just playing around and settled on Cocoa Zero, but we will probably have to do a trademark check later on and then make sure we don't conflict with Coca-Cola.
Exactly. It was a play on words, and we actually I'm really proud of what we came up with. So that's super cool. But yeah, Rodrigo, you actually said something really interesting that cocoa wasn't in mind initially. And I wanted to ask you, what was the motivation behind creating this alternative to traditional cocoa production?
Well, I think so. I mentioned briefly the importance of cost when you're trying to make a biotechnological product. Bringing down the cost can be done many ways. We're thinking about feedstocks, thinking about optimizing the process and yields, but also about making a product that has a higher cost. And I think that's where cocoa market, let's say, has been changing significantly in the past months and years, and prices are increasing, production is less homogeneous, there's higher demand, climate change affecting drastically its production, they're issues with supply chain. So it's an obvious target from that point of view.
Absolutely. And Oliver, in the short videos that we've been releasing recently, you actually touch on the scale of the problem that Cocoa Zero and yourself and Rodrigo are trying to solve. Can you just remind us maybe why is this such a big issue for the chocolate industry, for the food industry, actually?
Yeah, absolutely. So if you look back over the last few years, cocoa butter has always been more or less stable in the price. But about 2 years ago, I think it was that the price suddenly increased massively, like 2-3-fold. And the main reason for this, multiple, but one of the main reasons is, of course, climate change and changes in the environment. There's more droughts, there's stronger fluctuations in weather and climate and all these things. They put a stress on the cocoa tree, which only grows in tropical rainforest area, basically around the cocoa belt, so-called. So it's a very limited area in which you can actually grow. And if then there is these extreme weathers and climate changes, then there's an additional stress on it. On addition to that, there is pests that come and diseases. And so this puts a lot of pressure on the production. The supply decreased. Well, of course, our demand is stable or maybe increasing even. So that's why we have this huge spike in price, and it's still for 2 years now very high. And as far as I know, there's no really recovery in sight so far, because climate change is not going away, as you might have noticed. It might get even worse over the next years. So the cocoa prices will be very high for a while, which is an opportunity, sadly, for us then in this case, because that makes it, of course, feasible to look into microbial solutions.
Thank you for that. Yeah, because sustainability in food production has actually become a massive topic in the last few years. Cocoa being, highly susceptible to climate change, it faces huge challenges. What role do you think, also outside of Cocoa Zero, what role do you think biotech and synthetic biology can play in addressing these challenges?
So I guess the role of biotechnology and synthetic biology here is precisely on avoiding those problems associated with external factors we cannot control in the traditional cocoa production, which are associated with climate, weather, regions, year, supply chain, wars, etc. We can produce the products in a fermenter, in a factory, anywhere in the world. We're going to control the temperature, we're going to control the humidity, we can transfer that to any region where we can have some electricity and water supply and some feedstocks. So we decouple the environment from the production itself, which contributes to food security and control supply that can also adapt to the demand.
Amazing. Okay, and in terms of Cocoa Zero, the contribution of Cocoa Zero to solving these challenges, what makes Cocoa Zero different from current practices, from current ideas that could solve those issues?
Yeah, I mean, Cocoa Zero, our project is using yeast to produce these lipids, basically, and that make cocoa butter. The current approaches are, of course, to make cocoa butter from cocoa beans and then fermenting them and then make chocolate powder out of it and making then ultimately chocolate products. There is alternatives in which you can use other food oils, like rapeseed oil or palm oil, to make cocoa butter equivalents that can be blended into chocolate to basically reduce the amount that is needed. But our approach is then to use microbial fermentation for it, which then, as Rodrigo already mentioned, can be produced anywhere. It's completely uncoupled from climate, from other environmental factors, can use waste streams that might be coming from other industries as well. So we can get closer to the circular economy and are not using any cropland that we could use for other applications already. Instead.
Yeah, exactly. Well, obviously, Albert, Morgan, feel free to jump in whenever you've got any questions or you want to expand on anything. But Oliver, because you touched on something really, really interesting, can you tell us a little bit more maybe about the benefits and the sustainability factor of using this engineered yeast to produce cocoa fats instead of traditional farming? In one of the videos, you also touched on the chocolate belt, so-called chocolate belt, the region that cocoa plants grow, and you've actually explained it really well, how long it takes for the cocoa plants, trees to bear fruits. And that's a huge issue.
Yes, of course. So it's a cocoa tree. So it's a tree. As you can imagine, a tree needs some time until it bears fruit. In the case of cocoa, it's about 5 years for the first time until it bears fruit, and about 10 years until it really reaches its full yields. So if we lose trees now to diseases or wildfires, droughts, and all these kind of things, it takes a considerable amount of time for us to increase or recover this production or even increase the production, because it just takes so long for these trees to actually have some production. So this will always delay. If we now realize we need more cocoa trees, it will take 5 to 10 years until we can produce more. Having instead this fermenters to produce it, this is something we have fermentation technology in different places around the world. Biotech is growing for the last decades or more. So we have more and more places in which we can produce these products, and we can just ship our strain basically anywhere. They put the right feedstock, or we engineer it further to use different feedstocks, and then we can produce cocoa butter essentially anywhere around the world, as Rodrigo already mentioned.
Awesome. Thank you. Thank you very much. Oh, Morgan, I see you're raising your hand.
Yeah, I want to ask a bit of a wild card question. Something that I think is on my mind and might be on a lot of other people's minds that are listening to this and interested in this type of technology. What implications does this have for the farmers and the people that are actually producing it, where they're producing it in the chocolate belt? And has this project, are there any considerations that have been taken in this project or other projects with similar aims towards establishing or maintaining fair labor and trade economies between different countries and different regions? Because I think this approach is obviously very innovative and can be put anywhere, but should we put it anywhere, or should we be putting it where the trees are?
That's not easy questions to answer. I guess in every project we need to think about responsible innovation, right? And that's something we're doing here as well, thinking about what are the implications. Let's say if this works, what's going to be the implication in that farmer? I think we are still quite far from having any sort of implication in that particular farmer. And yes, one option is integrating fermentation in those communities, and that's something we're discussing for more larger other projects, and not only in food but in other also in energy and other aspects of biotechnology? Should we use, very often the feedstock we use for producing these ingredients or products come from agriculture. So potentially this could be a way to even valorize some of the waste products from the traditional cocoa making process, where some of the lignocellulosic materials and the leftovers from the plants that are not used can be taken and be used to make more of this cocoa zero. And then you have the farmers co-producing, let's say, the natural traditional cocoa bean, but also the biotechnological cocoa zero. That's way the community can grow together with the technology. But there are different scenarios, and I think there might be full projects that need to be carried out to understand what's the best way to implement those technologies at the larger scale, having this positive impact in the communities as well.
Thank you, Rodrigo. That's one of the best answers I've heard to that type of question so far. So yeah, thank you for that.
If I may give a slightly not as good answer as Rodrigo, perhaps, but I mean, the land by the end of the day is land. And so this land will not disappear just because we disrupt cocoa and cocoa lipid manufacturing. There's still other things that could be grown, everything from like cashews to coffee. So, I mean, as long as there's demand for other products that are grown within the same type of environment as cocoa is grown, I think people will still have jobs. I think initially it might be like requiring some sort of recalibration process and some adaptation by the farmers. But land is land by the end of the day. So it will just change to a different type of end product.
Thank you guys so much. Okay, let's dive a bit deeper into the science behind Cocoa Zero, shall we? Rodrigo, Oliver, what's been the most exciting part of the research process so far?
I think for me, this most exciting part now is the upscaling of this whole process. So the genetic engineering of Yerovia is something I have done in my PhD before. It's still quite magical for someone who hasn't studied this, but it's a quite standard procedure for people in our labs genetically engineering yeast. And having this strain and seeing that is producing the cocoa butter into composition as it should be is quite nice for the first time. But now getting to upscaling this production to actually, test its physical properties, not just looking at the fatty acids, is for me somewhat of a highlight right now.
Fantastic. And Rodrigo, is there anything you'd like to add to that?
Nothing more generally, and maybe for those in the audience that maybe are not as familiar with this technology, maybe explain a little bit how it works. So there's specific aspects in the cocoa or chocolate that are responsible for the particular flavor, taste, texture, and those are particular molecules, and those are the molecules we aim to produce with this so-called precision fermentation. And I think one way that we go about is understanding the natural process, understanding the natural plant and how that plant produces that particular molecule. And what we do in engineering biology is taking that particular genetic knowledge and transfer it to the yeast, so the yeast can produce exactly the same molecules. And I think that's a part that I particularly enjoy, which is that capacity, versatility, and power of nature, and transfer that to an organism that we know how to grow, we know how to scale, and making it produce that, I think, is still very interesting.
Absolutely. And before I'm actually going to ask you about the kind of the aim in the final product, can you guys walk us through the engineering of yeast to produce fats that mimic this kind of real cocoa butter? It could be even on a high level, obviously.
Sure. So simple for what our product really is. So we are looking at fats, so lipids, and these are triglycerides. It's like glycerol backbone. There's 3 fatty chains on that triglyceride. So this is the molecule we're looking for. The fatty acids can be different length. They can be unsaturated, saturated, so we have double bonds in them. And yeast is producing these kind of molecules, so triglycerides in general, naturally, like all organisms. But we have engineered it first to produce even more. We're using the host Yerovia lipolytica. It's a specific yeast that we've been using a lot in our labs. Yeast is an autogenous yeast. It produces a lot of lipids naturally, so we can engineer to produce even more. It's so efficient. And as a second step, after we have a lot of lipids, we modulate the fatty acid composition. So like which fatty acids are actually available in the cell for making these triglycerides, so putting them together, like 3 of them on a glycerol backbone. And then we engineered further to really mimic the right triglycerides. And that is then extracted and for cocoa butter.
If I can maybe add something now, maybe not about the engineering itself, but about the organism that we chose. So it's called Yerovia lipolytica, and probably many of you have eaten it already. So it's naturally found in cheese and jam cheeses and cured meat. So most likely, if you've eaten cheese or some cured meat, you've tested Yerovia already. So in the natural cheese-making process, you have Yerovia that is taking some elements from dairy or milk and transfer that into the kind of components of the cheese that contribute to that smell or that taste. So here you can think an analogy where the same organism is now in a different environment and it's taken the different feedstock, it's not milk in this case, and it's making a different product. So instead of cheese, we will be making this cocoa fat.
That is incredibly interesting. And how do you actually ensure that the final product and these fats mimic the texture, the melting point of real cocoa butter?
Well, that's Oliver having fun with the GCMS.
Exactly. So we are extracting the lipids from our yeast. And then there's an analytical method on the gas chromatography where we can literally see like which fatty acid kinds is it, like with the length and the desaturation. We can separate these species on the gas chromatography and then see how much of each is available. So then we can compare it to the real deal, the real cocoa butter, and see like how close we are, and maybe based on that do another rounds of engineering to maybe increase or decrease certain gene expressions so that we have more or less of some products. And when it comes then to the real properties, so these are all coming down to the interactions of these fatty acids with each other. So the longer you are, then there's more interactions. Usually that increases the melting temperature, which then is important for cocoa butter or chocolate products, since you want to have the chocolate literally melt on your tongue. You don't want it to melt already in your hands. You don't want to chew on a block of fat like butter. You want it to melt. So it has to have the real melting temperature that you have experienced. All of these things come down to the interactions on a chemical, physical level of these fatty acids. And once you can see that on a GC that the composition is close or even identical, then you know you're on a good path. But in the end, you have to isolate them again and then really just melt them and see when is it melting, when is it crystallizing.
This is incredible. And to everyone listening, if you want to read more about the research update for Cocoa Zero, make sure to head over to our ValleyDAO's Medium or Substack or Discord or Telegram or even here on Twitter. It's pinned, the article is pinned to the top of ValleyDAO's profile. You can dive in much, much deeper into this research project. And guys, because the implications of this research can go far beyond the chocolate, right? Do you think that Cocoa Zero potentially could influence other industries, such as plant-based foods, even cosmetics as an industry?
Yeah, I think because of the nature of the product we are producing is fats, lipids, and lipids are used for a wide variety of things, and that goes from, I think, other application in the food industry, and we have other projects in the lab where we are doing things like infant formula, so trying to mimic human milk fats, and we are producing those specific fats that are found in human milk. You can produce other things that contribute to like similar taste to meat. So some of the fats from meat are very, very special and contribute some of the taste. So we can produce those as well. But we can also produce other things that are not food related, like biofuels is a big example. Biofuels can be made or are made actually. Biodiesel is made from lipids from plants. And again, with plants, we have some issues about the relationship with weather, climate conditions, the competition with human food, etc. And we can produce those lipids that can be converted into biodiesel also with the similar technology Cocoa Zero is using.
Thank you. And I actually wanted to ask Albert as well a question. Albert, can you give us a little overview and how can the DeSci community can get involved with and support projects like Cocoa Zero? Because this is where ValleyDAO's mission of funding and supporting innovative research comes in, right? Could you tell us a little bit more and explain the importance of community support in DeSci-funded projects like Cocoa Zero and how can people actually get involved?
Yeah, absolutely. So there's different ways of supporting our mission at ValleyDAO. if people are willing to get their hands dirty, roll up their sleeves, and directly work together with us, we do have sort of like a research working group where we do everything from like business development to reviewing different research projects and the results that they are generating, so that we can essentially make better decisions on the next steps for each research project. So one example, the other day, we helped Oliver troubleshoot a couple of technical problems with the help of a couple of community members. So that's one example. And the other, and maybe sort of like simpler way, requiring less direct involvement, is by buying and holding the token. How I like to see and look at the token, it's essentially exposure to the success of everything that we do. So the success of the Cocoa Zero project, to Hempy, to Carta Forge, and to all of the future projects that will come out of ValleyDAO. And of course, there is the governance aspect of the token. So each token gives you a voting right, so you can help shape the direction of ValleyDAO and vote on things such as what we do if some of these projects start capturing value. What do we do with those proceeds? How do we keep, leveraging them and recompounding them to fulfill the mission of supporting the climate using biotech? So in my view, the two primary ways, but of course, token utility is something that is a continuous development process. So in the future, we hope to also introduce new types of utilities, such as if Cocoa Zero turns into a chocolate bar, can token ownership result in a discount for purchasing the initial product? And so, that's what's cool about crypto is these tokens, they can be so many different things. And so what we want to do is how can we deliver as much value as possible to holders?
I want to maybe add something specific as well that we were talking about internally earlier. This type of project, in terms of building a chocolate bar as the end product, like it doesn't just stop at creating the lipids. There needs to be flavor compositions, there needs to be sugar balance, and all of these other things that go into chocolate. It's not just like a one ingredient solution. I personally would be, and I'm sure the guys at Imperial would also be keen to work with and collaborate with people that are working on other components of the chocolate, or making other parts of the production of it more sustainable, secure, I guess, in terms of food security. And I would love to hear from those people, find out what they're working on, where things are at, and if there are any opportunities for collaboration on this, because I think we're going to all the support we can get to make this a reality.
If I can just maybe add what that means for us as researchers, like this. Tokens mean funding, and funding mean the capacity to move faster on the project, right? The capacity to get faster to a product, faster to the market, faster to a prototype that maybe can be tested.
Really well said.
100%. And guys, if you want to get involved, if there's anything that you'd like to help out with Cocoa Zero or any other research projects that ValleyDAO is involved with, head over to valleydao.bio or head over to our Discord server. There's a whole community that's eager to work together, to collaborate, to share their insights and expertise. And we're absolutely open to it. And what Albert actually said, this kind of first ever DeSci-enabled chocolate bar that potentially will happen. It's going to probably, change the world, and it's going to be absolutely delicious. So Rodrigo, Oliver, no pressure at all, but it does sound absolutely fantastic. Okay, Rodrigo, Oliver, so I wanted to ask you a little bit more about what's next for the Cocoa Zero project and your research. What could or should we be looking out for in the next 6 to 12 months? What are your kind of short-term and long-term to 12 months goals?
I can start with a general overview, and then Oliver can expand. I guess we always continue making the yeast better at producing the compound of interest. So that kind of is what we've been focusing on until now, but we will continue that developing along the way. But what Oliver was mentioning before is we're starting to think about the scale up and how we can actually moving from the milligrams of products that we can get in the lab scale to something more substantial that allow us to start testing actual composition, functionality, and how that can be used to generate products. Oliver, do you want to explain more on that?
Yeah, I think this sums it up pretty well. Now the strain has been engineered over the last year. Hopefully we can see the first formulations, so seeing at least enough of a real chocolate bar from our product. Nice. And then trying test it, as mentioned before, the melting temperature, crystallization, these kind of things. Does it behave like real chocolate? Maybe if we get it food grade, even to testing and tasting panels, and can really make a comparison to the normal chocolate, if you will, to our yeast chocolate. That would be really cool to achieve in the next 12 months.
Awesome. Thank you. And yeah, I actually got a question. What do you think, are there any challenges to scale up the production in the end? Because obviously, there's two sides of doing the research. There's kind of highly detailed research that you're exploring, that you're working on. But then when there's going to be the time to move on to a kind of full-scale production, are there any changes or challenges that you may be facing?
Absolutely. I think there will be challenges to face all along the way. I think some of the biggest challenges are still ahead of us. One being regulation and going through regulatory approvals for a food product, and the other one scale. And you mentioned that going to full production scale, that can mean many different things, right? That can mean producing a few thousand chocolate bars and sell them in a specific local store and can them, or it might mean taking 5% of the chocolate market, and that the scale is completely different, right? So I guess moving from now we're going to relatively small pilot scale to do further testing, but doing the next step towards a larger manufacturing capacity that requires significant funding as well to be achieved. I think that funding will be another challenge.
Absolutely. Albert and Morgan, can you tell us a little bit more about the maybe it's a little bit too early to talk about obviously commercialization of consumer-facing products from this research project. But I wanted to ask you a little bit more about the internal process that we have that tackles those issues and the kind of the market research that is being developed as well.
You're thinking about the project from a business development point of view?
Yes.
So the primary activity there is primary objective now is to get the fats in the hands of testers. So this would be chocolate manufacturers. And we're currently working on that. We just need to solve the scaling a little bit so that we can produce up to 250 to 500 grams of fats that we can distribute to different manufacturers. I would say that's the primary objective, and then gather as much data as possible on their properties, if they're good, if not. If the properties are good, that is an amazing signal. That means that we can start pursuing scaling up in a more dramatic sense. So dramatic, we're thinking 1,000 to 10,000 liters. Which could result in a batch of maybe, let's say, 100,000 chocolate bars. Maybe not, probably less than that. Secondary objective is to get these chocolate bars into the hands of consumers as fast as possible. I think there is a demand in the crypto industry for anything that comes out from a crypto project. There is always this wow factor from projects that manage to deliver a real physical product, but leading up to that product was all driven through crypto and through the communities that arise through crypto. So we have the same kind of attitude with the Hempy project as well, is we want to get something in the hands of our community, the DeSci ecosystem and the crypto ecosystem to really demonstrate that DeSci can really drive impact. That doesn't take, 10 years, which is probably going to take for a lot of the DeSci projects focusing on therapeutics, pharmaceuticals, for example. And so that's something we really look forward to demonstrating to the wider ecosystem.
Yeah, I mean, long story short, Mr. Beast, watch out, because CocoZero is about to take over.
Yes.
But hey, we're open to collaborate, so reach out, DM us.
We do actually have Dan in our team knows the guy that helps source some of the suppliers for Mr. Beast's chocolate bar, and he is based out of Belgium, actually, which is where I'm based. So, you never know.
This, absolutely love this. Guys, in the audience, if you've got any questions and you want to ask either Rodrigo, Oliver, Albert, or Morgan, please feel free to raise your hand and I'll get you here on the stage to take part in this discussion. Because we still have a little bit of time. Of course, Albert, Morgan, if you've got any other questions to Rodrigo or Oliver, please feel free to jump in and ask them. But yeah, Rodrigo, Oliver, one of my final questions actually, where do you see CocoZero in the next 5 years? What is your ultimate, as a researcher, as a scientist, what's your goal? What's your actual goal?
Okay, I don't know if this is 5 years, but the final goals for me will be really having this positive impact in people and planet. So if we can really alleviate some of the effects of climate change in local communities, on the supply, and hopefully we continue enjoying the chocolate that we all like.
Love this. Absolutely love this. That's why we're all here, to change the world, to change how people perceive science, to make the world a better place and to fight the climate changes. Oliver, is there anything you'd like to add to that?
No, I think this is a pretty good answer. I think it would be really nice to also see that a product that comes from precision fermentation gets the acceptance amongst the public to actually be consumed. I mean, maybe it still takes more time for other products, but if we lure people in with chocolate, I mean, who can say no to that? So maybe that's a good way into the hearts of people and sneaking this in. And then seeing that this is actually not anything, it's not letting you grow a third ear or something. So maybe that would be nice to see in 5 years, that people are actually willing to try chocolate that is made from precision fermentation.
Yeah, 100%. I mean, anything that you can call basically chocolate, just throw it at me and I'll be happy to test out. And Morgan.
Yeah, I had another question that might be giving some fuel to the DeSci ecosystem at large, but both Oliver and Rodrigo, what would you say are some of the biggest challenges you've faced during the research process in terms of like getting it off the ground, obviously understanding the problem space and like planning out the R&D, scale up, of course, if you can talk about some of those things.
Yeah, I guess our bread and butter is the R&D, right? We are a research lab. We are good at producing strains and producing product, optimizing them, making them more sustainable, more affordable at the lab scale, right? And I think the challenges that are coming with the scale up, with the commercialization, with tasting, consumers, formulation, that need to be done in collaborations, right? And that's what we are working towards at the moment. We are very excited about that. We are very collaborative. I'm happy to work with others. So if anyone in the audience think that they can contribute, please come and talk to us. We'll be happy to explore how we can do that together.
Yeah, add on question to that, and both to Oliver and Rodrigo, how do you ultimately decide what your next project is going to be about? Whether it's an improvement upon an existing project, or if it's completely new line of research. How do you ultimately make the decision? What kind of process do you use prior to that to help you make that decision? I hope my question makes sense. Let me know if not. I can clarify too.
I think it makes a lot of sense, and it's probably the most important part of the project is those initial steps where you think what's the problem you want to solve, and you investigate if the problem is worth solving, and if your technology or potential technology can really make an impact in addressing that issue. And it's very important to consider the big picture early on and don't be afraid of changing directions. And I think this particular project is an example of that, right? We've been kind of talking about different products, and it was not from day one that we focused on cocoa, right? It's been along the way after screening different things, seeing how our technology was evolving and improving strains when we identified this as a potentially interesting target. So it's a little bit the same thing. We're trying to incorporate aspects more and more of life cycle assessment. This is looking at the sustainability of a process. We want to have this positive impact in the environment. So it's important that we consider early on, is the process has the potential to be positive for the environment or not. And if it's not, maybe we need to reconsider the way we are envisioning the project. The same for techno-economics. So there is this process called techno-economical analysis that allow us to look at how a process to produce compound X from feedstock Y will look like. And you make several assumptions on what we know from other fermentation plants around the world, from we know how the typical yields are that we think we can achieve. And that gives you an idea of kind of what's the cost of your product at the end of a process at certain scale. And then you can comparing that with maybe competitor prices, or in this case, the cacao, but it can be any other, can my price point make it to the market or no? And very often you find it's a great idea has a great sustainability impact, but when I do my math, this is going to be 10 times more expensive, and no consumer is going to pay 10 times more for something that is a bit more sustainable. In that case, we can reconsider everything again, and we try to find something that works. And I think another very important aspect is like we don't know everything, right? We are constantly learning. That's what we do in academia. And the best way to learn is to talk to others. So we have a lot of conversations with industry. We have a conversation with people as well, with consumers, even with like school children, right? Through our outreach activities. And those conversations help us a lot to understand what industry needs, what are the actual challenges we can apply our technologies to solve, but also what people want to see at the end of the day and what people is willing to pay for.
Maybe a quick follow-up question, Rodrigo. Are you doing those TEAs and LCAs in-house, or do you have like collaboration partners on that?
We actually do both. We didn't have the resources in-house until very recently, but because we realized this is more and more important, some of our more recent hires bring with that capacity. We also established some partnership at Imperial College with other colleagues that are more expert in life cycle assessment. So several of our postdoc and PhD students are contributing to these LCAs, TEAs analysis, but we are also working with other partners in other institutions through academic collaboration, but also in industries. In some particular cases, we work with some consultants or some companies that are specialized in doing that as well.
Awesome. Thank you.
I'm curious to just continue on this line of questions. I think a lot of people are also interested in this in the audience. I mean, everybody uses LLMs these days, like ChatGPT, Grok, Claude, etc. I'm curious to know, Rodrigo and Oliver, like how have you been using this personally in your work, and like what is the greatest impact that it has had on your work as a researcher?
Can you repeat the question? Are you talking about LLMs?
Yeah, like ChatGPT, Claude.
So maybe I can give more a general answer, and Oliver can speak more about how he's using it in his actual day-to-day work. So I think what I wanted to share here is that my feeling and the feeling of other people in the kind of the food engineering space is that these technologies hasn't really been applied as much as in other fields in the food space. So there's a lot of opportunities to develop new models, for example, to understand the relationship between structure of proteins and functionality, or understanding composition of food and specific texture or taste. I think there's a huge potential to use multi-omics analysis to generate data that can inform new research directions guided by these LLMs and machine learning in general. We have a couple of small projects in the lab. It's not our core expertise, but we recognize that it's a growing area. So we're establishing collaborations, and we will be doing more work in the future. Oliver, you can maybe expand.
Yeah. I mean, on a very practical basis, when I'm using ChatGPT and such on a regular basis, like coding, because I'm not a bioinformatician. I'm a wet labber, so to say. So for doing quick coding to improve basically the high throughput of my data analysis, I'm happy to use these little AI helpers that are really good at this, and speeding up the process, or like very easy task of redefining text and such. But for this specific project, we have not used any AI yet, even though, of course, as Rodrigo said, there is a lot of potential also in predicting maybe protein functions and specificities and those kind of things. But in this project so far, we have not used it.
Okay. We're actually coming to an end of this episode. Rodrigo, Oliver, and Albert and Morgan, do you have any final thoughts? Is there anything else that you'd like to share with the community in this Proof of DeSci episode?
Well, not to put Rodrigo on the spotlight too much, but he's always, his lab is always, and team is always growing. There seems to be a lot happening. Rodrigo, are there any opportunities coming up for PhD positions or other types of studentships and collaborations that might be of interest to anybody listening?
Yeah, I mean, we're always keen on people to reach out if they want to join and know more about the lab. We're going to have 2 PhD student position next year. They will be advertised probably around January next year. So the way it works in Imperial College is PhD students start in October. So we are finalizing the last interview rounds at the moment for students to start in October, but we will have 2 more positions next year, and we will also expect to open some postdoc positions in the next couple of months.
Okay, well, I think, guys, that's a wrap on today's episode of Proof of DeSci. A huge thank you for this inspirational conversation to you guys, to Rodrigo, to Oliver, to Morgan, to Albert. Thank you so much for joining us today and sharing the work behind Cocoa Zero. From my personal opinion, it's inspiring to see how DeSci is not just a concept, but it's a massive force driving real world change in industries like chocolate production. And if you're excited about what you heard today, make sure to stay connected with us at ValleyDAO, like I said before, on Telegram, Discord, here on Twitter. Go and follow Albert, Morgan, Rodrigo, Oliver. Go and follow Bobby as well. We're here to continue to fund and support the incredible innovations. And if you haven't yet, check out the Grow Token and how you can get involved in funding the future of science. And once again, thanks to everyone who tuned in. Your support makes all the difference. We'll be back soon with more Proof of DeSci. And until then, guys, keep pushing the boundaries and keep proving that DeSci works. Thank you so much for being here with us today.